Hello, good morning. So today we will discuss something on the BGP and traffic engineering on the BGP. We will start with the local preference, right? So local preference is a very important tool in the BGP for the traffic engineering or traffic steering. Uh, it doesn't matter whether you're working in the cloud or you're working in the legacy system or whether you are working with the new SDN type of technologies. The BGP are the protocol which have been used extensively on all kind of a network, right? So this is a very basic setup, and this is what we need to understand. What is a route steering or a traffic engineering or the route filtering? So what we have a data center, and that data center is originating a route 10.1.1.0/24. We have an R1 and R2 which is connected with an R3. Okay, and we have a two links over here, EBGP. They have the EBGP neighborship with a link A and a link B. Between the R1 and R2, we have an IBGP, and this is with the IBGP. So one subnet is hosted in the data center 10.1.1.0/24, and the other subnet is a LAN subnet 192.168.1.0/24. So this LAN subnet has to talk to the data center network. So there's a clear difference between the route and a traffic. So both work in an opposite direction. So DC subnet is originating a route, right? So why it's originating a route towards the R1 and R2. So you can see this is a route that is going towards the R1 10.1.10/24 and 10.1.10/24 R2, R1 and R2. Okay, so both of them are receiving the route from the EBGP. Our concern is that there is some issue with the link B. We have to use only link A for the traffic, interesting traffic. So both direction is in opposite way. So both route and traffic works in the opposite way. Okay, so what we have a interesting traffic coming from the 190 LAN subnet to 10.1.1 should use the link A. So what we could do over here. So once we don't want to make a change on the DC subnet router, we have to make a change on the we have a full use on the R1 and R2, whatever the change we can do in the R1 and R2. So the best way is once we receive the route, right, we can set the local preference. So we can do the local preference over here, R1, and leave the local preference of R2 as default. So for the local preference, it's a three feature. Local preference is a local to AS. Okay, so this is one AS. Suppose AS 100 and this is an AS 200. So this is a one AS. So local preference, don't leave the AS. So local preference 300. We will and the first feature, local preference, is local to the, that is why its name is a local preference. Local preference is a local to the AS, and local preference is the s- higher is the better. So what we have, and the default value is a 100 in the Cisco. So what we can do, we can set LP is a 300 on R1, and R2 we can just leave it like that, 100. So whenever the subnet come, right, the route come, it will have an, so BGP works with an attribute. They don't have a metric like that, they have a list of an attributes. So list of an attribute is something, list of a features, right? You are a guy, you're wearing a shoes, you have a shirt, pant, everything, that's a feature, that's an attribute that define you, right? You're carrying a purse, mobile, that's an attribute. So so with this BGP also, they have a roots with the attributes. So LP is a 300, LP is a 100. So it's a by default. So which one is higher? This one is an higher. So we have a route. So once we will get into the R1, we will set an local preference 300, and this is also, we will leave it like 100. This is a local to the AS. Okay, so it will, this same route will go to the R3 also. So R3 will receive this route, two type of a route. One is a 10.1.10/24 LP 300, local preference 300, and 10.1.10/24 the LP is 100, right? So it will receive the two routes. So the, what is the best criteria it can choose, it will, so the local preference higher is the better, so it will choose this link, right? It don't have a control over this link. It can go to like this, from this, and there is, but the exit point with the link A, either it will go like this or either it will go like this. It depends on the this metric, this cost, but the overall exit point would be the this one. Okay, so this is a traffic. So we need to understand the route and the traffic. So interesting traffic will start from here and it will go to this. Inside it will start from here, then it will go to here, and this will go to this, right? So exit point would be always an R1 where we have a set a local preference greater on this gateway routers. So it's a 300, it's a 100, right? We can use directly with an attribute local. There's an option for the local preference or use the route map. And local preference always towards the inward direction. When we receive the route, at that point of a time only we will set the local preference, and that is inward direction when we receive the route. So that is why when we receive the route, at that point of a time we are setting the local preference. Okay, and it will receive the local preference 300. It will always go via these router, via this or via this, but the exit point will be this. Okay, we have one more scenario. Okay, we have one more scenario like this. We have a router. Okay, R1 and R2. We have this router as a BGP. This is the same what we have from the last picture, right? But here with this, we have removed the RT. We have an L3 switch, and we don't have an IBGP. We have an OSPF. We have an OSPF over here. We have an OSPF over here, and between R1 and R2, we have an IBGP. Okay, so DC subnet originate a route. So it will receive, it will go to this R1 and it will go to then R2. Okay, R1 and R2 receive these routes with a as a EBGP. Can we use a local preference over here for the traffic engineering? Can we do the local preference over here when we are doing a redistribution over here? That it should always go via this link. Can we do it? Because the OSPF could not understand the uh, what do you call the local metric. OSPF don't understand the local preference, right? And we don't have, I don't think we have a link. So IBGP, this is an IBGP, this is what, and this is, so we, as per as my understanding, we will use our redistribution is happening over here. Redistribution is happening over here. Okay. So what we can do is the best solution instead of using the local preference. What we can use over here, once we are advertising these routes as a E1, okay, because the redistribution is happening over here, and the redistribution is happening over here. On the both side, we have a redistribution as happening on the both the routers. So what kind of a router this is? This is an ASBR router, right? And ASBR router, what they will do? They will generate the LSA5. Okay. So if you want to prefer this link A, what the best solution we can do is while doing the redistribution, okay, we can give R1 that okay, you advertise this route 10.1.1.0/24 as a E1 route, and you can advertise 10.1.1.0/24 on R2 as an E2 route. Okay, we will set a metric. So you can see we will set external metric 10 and metric type 1. Set metric 10 and metric type 2. So both of the external metric are same. Okay, and the but the type are different, E1 and E2. Once it will reach to L3 switch, it will have this both the route 10.10/24, 110/20, and 10.1/110/10. Okay, so cost to reach the external is same, 10 plus 10 20 and 10 plus 10 20. So that what is the next deciding factor over the next deciding factor over the type of a route. So the type of route E1 and E2. So E1 is always preferred over the E2. So E1 is always preferred over 2. So this is the path it will choose. So the traffic will flow with this via the link A. Okay. So it will always give this to the ASBR R1. So this is another way we can do it. The next session will describe on the how we can do with the play with the BGP AS path, in which direction it's an outbound or inbound direction. Okay, thank you.